Hello students, in this video we are going to derive the equations of motion by graphical method. Here I am taking the velocity time graph as shown in figure. When time t is 0, the velocity of the body is nothing but u, and after that the velocity is increasing as shown in figure. At the time t, the velocity of the body is v. I am naming it it is O, this point is E, this point D, point B, point C and point A. Here OA value is equal to ED value is equal to U, that is nothing but initial velocity. At the same time OE is equal to AD is equal to time t, and OC is equal to EB is equal to V. Now we will derive the first equation of motion. From the velocity time graph, by finding the slope will give us acceleration. Acceleration of this VT graph is nothing but BD divided by AD. Here BD is nothing but V minus U, AD is nothing but OE, that is equal to T. From this V minus U is equal to AT and V is equal to U plus AT. This is the first equation of motion. Coming to the second equation of motion. For our convenience purpose, again I am drawing the same graph. It is O, point A up to here, velocity U. The velocity is increasing. And time taken is t here. Here, to find the second equation of motion, we have S is equal to ut plus half at square. We want S, that is a displacement. How we will get the displacement from velocity time graph? From velocity time graph, the displacement is nothing but area under velocity time graph. So S here is area of the trapezium OABE. We can write here area of the trapezium is nothing but half of the sum of the parallel sides OA plus BE are nothing but parallel sides into perpendicular distance. Perpendicular distance is nothing but AD or OE. Here half OA is nothing but U plus BE is nothing but V. OA is T. That is equal to half U plus this V value in the first, from the first equation of motion we can write U plus AT into T. That is half of 2U plus AT into T. If you multiply this one becomes UT plus half AT square. That is displacement of the body. Now coming to the equation 3. Again, for your convenience purpose, I am taking the graph again. Time axis, velocity, point A, B, C, D, E and O. Time taken T here, velocity, V here, it is initial velocity, final velocity. Here also, the third equation of motion, V square minus U square is equal to 2AS, we have to derive. Here time is not there, time we have to eliminate. So to derive the third equation of motion, there also S we need to find out. S is the displacement traveled by the body. Again we will use the same. S is equal to area of the trapezium. Area of the trapezium. OA BE. S is equal to half of OA plus BE into OE. That is equal to half OA is U, BE is nothing but V and OE is T. That is half U plus V. This T should be eliminated. From the acceleration formula, A is equal to V minus U by T. From the T, I will write V minus U by A. That is equal to half V plus U into V minus U by A. That is nothing but half into V square minus U square divided by A. From this we can write 2AS is equal to V square minus U square. V square minus U square is equal to 2AS. These are the three equations of motion. The limitations of these equations of motion is, these equations of motion are valid only if the body is moving with uniform acceleration. These are applicable for uniformly accelerated motion. Thank you.